Distinguished guests, ladies and gentlemen, in relation to their agenda item 5 on developing a collaborative platform for marine scientific research in the mid-ocean ridges in the Indian Ocean, I would like to share some insights from a recent ISA workshop held for the area in the northern mid-Atlantic ridge. The ISA workshop on the development of a regional environment management plan for the northern mid-Atlantic ridge concluded about 2 weeks ago. Collaboration and capacity development were one of the 4 thematic topics that were discussed at the workshop. In view of their relevance to this agenda item, I will be presenting the key summary points based on the draft workshop report and in discussion with the moderator of this group discussion, Dr. Gordon Patterson, who unfortunately cannot join us today. When the Northern Mid-Atlantic Ridge Workshop discussed collaboration and capacity building in the context of developing and implementing the Regional Environmental Management Plan, participants focused on the following questions. First, what could be the priority collaborative activities? Second, what could be the priority capacity development activities? And lastly, how can ISA contractors jointly identify and implement priorities for monitoring and research? At the onset of the discussion, participants noted a wide range of collaborative and capacity development activities that are being undertaken under the auspices of ISA. For example, ISA has developed diverse collaborative agreements with several international and regional organizations. As highlighted in the ISA Action Plan for Marine Scientific Research, further efforts are needed for enhancing scientific partnership for sharing and processing of data and information in support of fulfilling ISA mandates. There has been increasing collaboration among ISA contractors and between the contractors and the scientific community. As noted in a recent report of the Chair of the Legal and Technical Commission, such collaboration has extended to taxonomic standardization, joint environmental surveys and data collection, linkages with international research programs, as well as data collection in areas of particular environmental interests in the Clarion-Clipperton Zone. Such collaborative efforts would provide a cost-effective way for strengthening the knowledge base for biodiversity assessment and protecting marine environment at the regional scale. On capacity building, existing programs and activities include the contractor training program, the endowment fund for marine scientific research, as well as the internship program. The IASA China Joint Training and Research Center was also established last year and officially launched recently, providing a new platform for ISA to promote capacity development, in particular for developing countries. At the panel discussion tomorrow, you will also hear from the representatives of the Joint Training and Research Center and former ISA trainee on their perspectives and views. A total of 15 collaborative activities were identified as priorities in the context of the Regional Environmental Management Plan in the Northern Mid-Atlantic Ridge. Due to time constraints, I will not go into the details of each priority activity, but would like to highlight some that could be relevant to this agenda item for the current workshop. Prioritization of knowledge gaps was considered necessary to guide collaborative efforts. A number of actions were suggested, such as the alignment of monitoring and research programs among different ISE contractors. A joint forum was also suggested, which can be facilitated by the ISA for the review of knowledge gaps and priority actions. Risk analysis at the regional scale, which can be achieved through the development and application of frameworks and methodologies, such as cumulative impact analysis and scenario planning, to identify and assess risks to ecosystems, habitats, communities, and species. Understanding plumes and technology for plume reduction. This is an area that would require collaboration among contractors, the engineering industry, and scientific community that have relevant experience. Combination of different methodologies, such as field experiments and models, were considered useful. And it was also mentioned that there are studies on plumes and their impacts from small-scale activities and tests, which could provide useful references. ISA can facilitate the sharing of knowledge and information from such studies. For technology development, it is important to better understand how technology is evolving, the impacts of new technologies, and how technology advancements can improve our ability to monitor and protect the environment. Engaging the engineering industry would be crucial in this case. And ISA could play a role in establishing a forum to bring together engineers, contractors, and scientists. Collaboration between contractors and the scientific community in undertaking environmental impact assessments, EIAs, can also provide a useful way for bringing together different knowledge and expertise. Structural property is critical for ecosystem function. It was highlighted that maintaining ecosystem function is often a key management goal in regulating various activities, and this can be achieved through experimental studies on tipping points, beyond which further loss on structural properties may impact on ecosystem function, as well as studies on community structure. Thresholds are needed for various management needs, from the application of area-based management tools to the control of impacts from plumes and potential pollutants. It was noted that a lot of work on thresholds have already been done in other offshore industries. Development of thresholds can benefit from dialogue and collaboration between the ISA and other competent regulatory bodies, as well as scientific institutions. A phased approach to thresholds development was also suggested. The first phase would be to define which thresholds should be developed, and the next phase will focus on defining these thresholds. Regional scale mapping and modeling are also considered important for designing monitoring and research activities. This can build on the ISA deep data database and benefit from partnership with existing regional initiatives and programs. Developing regional scale oceanographic models, as well as building a fleet of AUVs, were also suggested as cost-effective ways for large-scale studies and mapping. Intercalibration for comparative analysis was considered as an important step in regional level studies. Intercalibration studies will be needed to ensure coherence within deep data and to bring together historical, academic data as well as more recent data for meaningful analysis. Developmental models and methodologies for harmonization of data will be useful, as well as intercalibration of sensors. This can also build on experiences and methodologies developed in other disciplines, such as the climate change science. Taxonomy and biogeography are important for understanding connectivity, larval biology, community composition, and ecosystem functioning. This priority activity can be achieved through compilation of a list of taxa in the region, practical taxonomic workshops, as well as intercollaboration studies and workshops organized by the ISA. Connectivity studies. This priority activity can be achieved through workshops and multidisciplinary research projects using a range of different methodologies, as well as participation of scientists during the contractors' exploration cruises, so that different populations can be sampled for connectivity studies. Multiscale long-term monitoring is another important area of collaboration. The challenges of undertaking monitoring within a realistic timescale was highlighted, and it would be important to identify key parameters for routine and possibly real-time monitoring. This priority activity can be achieved through the development of network sensors AUVs, energy supply, and communication systems. Partnerships with the engineering industry to develop real-time, regular, and long-term monitoring technology, and incentivize funding and investments from contractors as well as third parties on the development of deep-sea observatories. Larval studies were considered important to understand the resilience in species and the associated risks. This priority activity can be achieved through joint field and lab experiments developed by contractors and scientific organizations. Migratory corridors, which can build on existing research projects and collaboration with other international organizations. Further studies through the tracking of pelagic species were also suggested. In addition to these individual action points, a number of cross-cutting actions were also identified, which could contribute towards multiple priorities. These included the sharing of cruise information and opportunities to participate in such cruises through ISA or other platforms. Several priority capacity development activities were also identified, which included further alignment of ISA training programs with the priorities identified by developing states, implementing recommendations from ISA workshop on capacity development, resources, and needs assessment held in February 2020, as well as the report by the Secretary General on implementing a pragmatic approach to capacity development, which is currently being considered by the Assembly. Providing further opportunities for earlier career scientists in linkages to the work of contractors through internships and other means. And finally, raising the awareness of decision makers in the funding bodies on the work of ISA and to work towards the establishment of relevant funded scientific collaborative programs. It was recognized that the interest for undertaking research and monitoring differ between scientists and contractors. Research scientists are often rewarded for undertaking novel, curiosity-driven research, while much of the contractors' work is focused on environment baselines and monitoring as part of their obligations under the contract. However, collaboration among the contractors and between the contractors and the scientific communities can be promoted with improved access to funding, cruise time, samples, and data. And it was also mentioned that it is important to identify key parameters and essential biological variables for monitoring at a range of spatial and temporal scales, which could guide the design of joint monitoring programs and activities. With the above, I hope the key messages being shared from ISA's recent workshop can inspire all of you in your deliberation under this agenda item. Thank you very much for your attention.